Good morning students, welcome back after puja vacation. So I am going to discuss now chapter 9, which is current electricity. In this chapter, in current electricity, we will be discussing a few topics today. So topics are sources of electric current, means where from we get the current. So next one is what is current, means what do you mean by current. Then symbols of different components in a circuit. We have seen in a circuit there are a good number of different components, and by the symbol only we can understand what is what. And the last topic today is simple electric circuit. Now let me start with the sources of electric current. There are two types of sources, AC and DC. Usually what we get in our home or in hospitals or in school, college or in marketplace, all are coming from AC, that is called mains. And what we use in our say torch or say camera, it is called DC. So DC current means is a current of constant magnitude and flowing in one direction, means DC current whose magnitude remain constant and it flows only in one direction, whereas AC is a current which changes its magnitude and reverses its direction with time, means with time the direction of the flow will alter. That's why it is called alternating current. In short form, it is AC. Now we will be talking more about DC, and alternating current we will be discussing only in class 10. So let me discuss for DC. An electric cell is a source of DC. So what is electric cell? Usually what we get in the market, I am trying to draw a simple sketch of that one. So this is more or less is a dry cell. It is a dry cell. This one is brass cap and whole chemical is kept in a vessel made of zinc. So zinc vessel. So in this zinc vessel we keep electrolyte. So here brass cap behaves like positive terminal and zinc vessel behaves like negative terminal. When we connect with a wire having a bulb, we have seen the bulb starts glowing. So we can say an electric cell is a source of DC which converts chemical energy to electrical energy, means within the cell there is some chemicals. These chemicals will do some reaction, and because of the chemical reaction somehow electricity starts flowing, and that one we will discuss later on. Somehow electricity starts flowing and the bulb starts glowing. Okay, so this is a source of DC. In a cell there are electrodes, two electrodes as I mentioned here, positive electrode and negative electrode. Positive electrode sometimes we can say it is anode, and negative electrode we can say it is cathode. And electrolyte we use here to convert chemical energy to electrical energy. Now again, cell can be divided into two types. Primary cell, examples dry cell, Lagrange cell, simple voltaic cell, whereas secondary cells are what we use in car. Normally we say car battery. Actually secondary cell we can say lead accumulator or nickel iron accumulator. Why we are talking about it is called accumulator? Because secondary cells actually it accumulates the charge while we do charging. So that means during charging we can say it during charging it accumulates charge, and that charge starts flowing while we use it. So primary cells which provide current as a result of irreversible reaction, means irreversible chemical reaction, means if this dry cell or any primary cell is used, then electrolyte will do the chemical reaction. After doing the chemical reaction, somehow the electron starts to flow, and then we say that current is flowing. And while this one reaction is going on, later on we can say this chemical has no energy to supply the electrons. That time we can say the cell is dead. That means it can only use once. If we used and then when it cannot flow any more current, we can say it is dead and it has to be thrown out. That's why we can say primary cells. Whereas secondary cells are those provide current as a result of reversible chemical reaction. What is it? Let me discuss. In a secondary cell, first we will supply current, and when you supply current, that is called charging. So during charging, it accumulates the charge. It accumulates the charge. So again once more, secondary cell during charging, it accumulates the charge, and that charge is stored. That's why secondary cells is also named as storage cell or storage battery. So this stored charge will be sending the current while discharging. So that's why you can say it is reversible. Reversible means we can charge, again we can discharge. But in primary cell, once we use, that is discharge, so it will be completely discharged, it cannot be recharged. Whereas secondary cells can be recharged. That's why you can say it is reversible reaction. Means for secondary cells, charging and discharging will take place one after another. There are few types of secondary cells. Normally we use lead or acid accumulator and nickel iron or alkali accumulators. Now we will go for second topic. What is current? Current, actually it is the rate of flow of charge across a cross section of a circuit. So that means we can say when charge is flowing, we can say that current is flowing, and that current symbolically we can say Q by T, means the rate of flow of charge. Means when you divide by time to the full amount of charge, that is called current. So current is the rate of flow of charge. Now what is charge actually? Which charge flows? As you know, only electrons can flow. Positive charge cannot flow. So here charge we can say Ne minus by T. N stands for number of electrons. E minus means charge of one electron. So full charge means whole amount of charge, we can say the product of the number of electrons to the charge of one electron. And if you divide by time, we can say it is the rate of flow of charge, and the rate of flow of charge is called current. So ultimately we got current I is equal to Q by T, Ne minus by T, means current is the rate of flow of charge. Clear? Now since it is one of the physical quantity, so we can use for measuring. So to measure we need proper units. Unit is ampere. Ampere, capital A we can write, or AAMPERE you can write, or we can write another way. Charge is measured in coulomb and time is measured in second. So coulomb second inverse. So you can use any one of them. Either capital A stands for ampere, or we can say coulomb second inverse, right? Now we have seen that current flows. Yes, current flows. Let me discuss. Suppose there is a cell. Usually this is the symbol of cell, and this is positive terminal, this is negative terminal. Now if you connect through a resistor, we have seen current starts to flow from positive terminal to negative terminal. This type of current is called conventional current. This is called conventional current. but sorry, but negative terminal is the negative terminal actually is the amount of electrons presence here. So we can say from negative terminal to positive terminal one current flows, that is called electronic current. Electronic current, yes. Actually electronic current is a real current because only electrons can flow from negative terminal to positive terminal through external circuit. But usually we say that current flows from positive terminal to negative terminal. That one we normally use as conventional current or simply current. Again once more I am telling you, electronic current is the current due to the flow of electrons which flows from negative terminal to the positive terminal. But normally we say that current flows from positive terminal to negative terminal, and that current we put another name, so called conventional current. But usually we can say only so called current. Either you can say conventional current or simply current. Now I am going to discuss the third topic, symbols of different components in an electric circuit. In an electric circuit we use so many different components and each of them has some symbols. So we will be discussing one after another. First one we will be talking about sources of current. Sources of current, as you know, we have already learned there are two types of sources, DC and AC. So symbols for DC is here. One positive terminal, one negative terminal, that is called a cell. When a number of cells are attached in series, that is called battery. These both are the source of DC. And another one, the source of AC is here. Normally this is the symbol of source of AC. So sources of current is two types, DC and AC. DC can be cell. When a number of cells are attached together in series, it is called battery. And this is AC. AC has as such no positive or negative terminals, whereas cell has positive as well as battery has positive and negative terminals. For cell there is no as such terminals. Second component we use key or switch. Normally key is a plug type of key we use in practical. So this is the symbol of key. When the key is not in off position, it is like this. When the key is in on position, we put this plug. This is the symbol of plug, and that is for on position. So when it is in off position, there is no as such plug, and when it is on position, there will be plug. So this is normally we use for key, and for switch we use, this is the symbol of switch. This is the symbol of switch. So when the switch is in off position, there is no direct connection, and when the switch is in on position, we will just do connection. Again once more, when the switch is in off position, we keep some gap, and when the switch is in on position, we just do this one, so that the switch is now in on position. Key is also in on position, key is here off position. Third symbol we use here, rheostat. Rheostat, actually symbolically we can say this one, or we can say this one. Rheostat is used to vary the strength of flow of current. whenever it is necessary. Means by putting more resistance by the help of rheostat, we can reduce the current, and by reducing the resistance in a circuit, we can increase the current. Again, once more I am telling you, by rheostat we can increase or decrease the strength of flow of current. When we put in the circuit more resistance, less current starts to flow, and when we increase the resistance in a circuit with the help of rheostat, we can decrease the strength of flow of current, right? Now, fourth component, ammeter. Ammeter usually we attach in a circuit in series. Ammeter is used to measure the strength of flow of current, and symbolically we have one circle written as A. A stands for ammeter. It has two terminals, positive and negative. Make sure that positive terminal should be connected to the positive terminal of the cell or battery, so that current through the ammeter will flow from positive to negative terminal. And ammeter always connected in series. 2 points you have to keep in mind. Ammeter is used to measure the strength of flow of current, which can be attached in a circuit in series, and positive terminal of the ammeter will be connected to the positive terminal of the cell, so that current will flow through the ammeter from positive terminal to negative terminal. If positive terminal is not mentioned, then this terminal will be marked in with red color, and the negative terminal will be marked with black color. Okay. Next one, voltmeter. Voltmeter. Voltmeter, symbolically we write as capital V. It has also positive terminal, negative terminal. Again, positive terminal will be connected to the positive side of the cell, negative terminal will be connected to the negative side of the cell. And keep in mind one thing, the difference between ammeter and voltmeter. Voltmeter is used to measure the potential difference between the two terminals of a circuit. Voltmeter is used to measure the potential difference between the two terminals of a circuit, whereas ammeter is used to measure the strength of the flow of current, and voltmeter is connected in parallel. Again, once more I am telling you, ammeter connected in series, voltmeter is connected in parallel across the load. Okay, the next one is galvanometer. What is galvanometer? Galvanometer is a device which is used to measure, it is used to measure the weak current, as well as it shows the direction of the flow of current. Galvanometer is used to measure the very weak current, and it also shows the direction of the flow of current. Usually, galvanometer symbolically we write capital G. Of course, it has no positive or negative terminal. It can be connected anywhere else, as such no problem. So, we have discussed here symbols of different components used in a circuit. Now, we will go for the last topic, simple electric circuit. Simple electric circuit. In a simple electric circuit, normally we put one bulb that is called load, and then we will be attached to one ammeter, then there will be key, then there will be either cell or battery. Okay, I am keeping here a cell having two, okay, I am keeping here one battery having two cells, then there will be as such rheostat. Okay, let me do little better way. And over here we will be keeping one voltmeter, to measure the voltage across the bulb or cell. So this is positive terminal, this is negative, positive, negative, positive, negative. Now the switch is in off position. Switch is off position means no current is flowing through the bulb and bulb is not glowing. Now as soon as the switch is on, means plug is kept here, then it is in on position. Now current starts to flow from positive terminal through the ammeter, through the bulb, and the bulb is glowing, right, and the current is flowing back and it goes to negative terminal of the battery. Now what is the function of the rheostat? If we bring this point here, then less resistance comes in the circuit, more current starts to flow through the bulb, which you can see from the ammeter, and the bulb will be glowing with more light. And if we put the resistance in the circuit more, then the less amount of current will flow through the bulb, and the bulb will be decreasing its intensity. I think you understood what I am going to explain. Again, once more I am telling you, cell or battery, key, ammeter, load or bulb and rheostat all will be in series, whereas a voltmeter should be kept in parallel across the load whose voltage we are going to find out. Okay, thank you so much.